Hello, everybody. I'm Martin. I will be working with you for making the practical tasks with this Power Logic P5 relay. So I'm making this video to explain some of the necessary information to you about how to use the relay, what is the interfaces of the relay, how to use the manual, and how to basically uh, create a program and download it to the robot. Let's go. I made this file so that this will make so that keep everything in order. Part one, I will explain the eSetup Easergy Pro interface, what all of the tabs that are there, what kind of settings we can do there. Then how to use the manual of the this relay, how to read and write the program to and from the relay. These are the three parts that I want to explain here. Let's go to the I close this program. If you open the software, you will have this kind of view. Right now I'm not connected to the relay, so I cannot go online. This is offline. If I want to connect to the relay, I will press this one, and here the software is checking if there's any connection. It tries to find the connection to the relay. Right now it didn't find anything, Ethernet or like with the front ports of the relay. Let me show you a picture of the relay. So this is a picture of the relay. First, we have this display. In this display, you can see the Mimic 1. Later, we will see in the program how to create this mimics, basically the small like schematics of the objects, and then what kind of information we want to see here. All of this we can set them. These are the buttons for navigating, like home button, information button, reset button. It's not reset, it's for releasing the like trips. Up here we have like different LEDs that they are just giving us different signals. When it's on and everything is good, we will have this screen and this screen. These push buttons that are here also, this is the wherever we see control button, they are here. We will use them we have to basically set them up in the control tab of the software. We can decide what these buttons will do. These buttons that you can see, F1, F2, F3, these are called function button, up to F7. These are called function button. By default, they are not doing anything. But you can decide to do what to do with them. Like, for example, I decide that if I press function button 1, some output will turn on, or something will change in the screen, that is. And here you can see the this button is like a remote control or local control. If it's local control, we are controlling it from the computer that's connected to it or from the panel. Remote control means that it will give us the possibility to control from over the internet from far place. So this is our relay. So we have the mimic control buttons, 0 and 1, remote, local, and this LEDs also. These are LEDs that we can basically in the program decide which LED will turn on when. And so those, okay, for this part, the interface of the relay, we can see. And here we have two ports, one USB port and one mini USB port that they are, if you remove this cap here, you will have that. So those are used for connecting via USB to the relay. So right now, we are not connected to that. So let's go to the software. We are not connected, so right now I'm closing it and I will go open a project that I have saved in the computer, like program 1, and the EPZ is like the format of the file. I would open that and then I will go through all of these tabs that are here. I try to make it very quick so that will be easier to follow. Introduction to eSetup and Easergy Pro. This is what we are in the middle right now. This is an image. This file I will add to the YouTube as a link so that you can download it. So we have 9 different tabs here: general, measurement, control, all of them up to the documentation. Let's go see what they are doing. The general is basically for giving the device information. You can read this other text by pausing the video. I just want to make the video as short as possible. Time and date, you can set the ratings for the transformators, like current voltage transformators, and many other settings you can set. These are the first settings that we have to do for the relay in each program. Measurements are basically for following the situation of the current, voltage, power, and so on. Then the control tab is for deciding what breaker to control, interlocking of the objects, control modes, what kind of remote control, disabling the control behaviors, all of those will be done here. Protection, we have maybe up to 100 protection functions that here in this tab we will decide which one to be activated. The setting groups for them, we can set the trip logic we can create. In the matrix, we will have matrix tab, signal routing, logic combination, and output. Later in the software, I will explain all of those. And in the log, we will have the event log, fault record, maintenance log, communication protocol settings, network parameters, like giving the IP address and others. Data mapping is here. In the device test, we can see the device diagnostic, input output testing, simulation mode we can have, and then documentation, configuration, reports, parameter lists, and the verification information. So these are the 9 parts that I'm going to explain inside the software. So first we are in the general tab. We can give different name and all the other details. They're self-explanatory. They are simple. You just need to read them and then select based on your project what you want to name this one. In the scaling, you have for every CT that is connected to the CT is current transformator, VT is voltage transformator. And for each of the CT or VT that is connected to the relay, we have to set, we have to set the primary and secondary of that. For example, here, if it is 200, it means if we have 200, and when you make a change in the project, it will turn blue. So that you can like mark it. You can notice that something is changed there, and you want to update. Right now, I turn it back to the 100. You see, it becomes white. Let's say if this is 100 and this is 1, what it means? It means for every 100 ampere that is passing through the primary of the CT, the secondary of the CT will have 1 ampere. So if I get if I have here if I measure, if I am, my setting is like this, and the relay I'm getting like 2 amperes, it means real amps in the network is 200 amperes basically. So all of them are okay. Here we have the phase rotation. Also, we can choose that the phase rotation to be ABC or ACB, clockwise or counterclockwise. And the voltage measurement mode, we have different types here that you should refer to the manual. If we are selecting, for example, this 3LNVN, we have to select the connection diagram based on this measurement mode. On the manual, there's different schematics for the connecting the CTs to the relay. So power direction is we put it outgoing like the default it is, and then Celsius is the temperature unit that we want. The mimics. Let's go to the mimics. Here you can see we have 10 mimics. The mimic 1 is this. This is what we were seeing in the display. This is the mimic 1. We can select other mimics to see other mimics also using these buttons. But right now, let's see what it means. We have the tools to make this. We have all of these tools for creating the mimic that we want. When we are importing, for example, a contact, like normal open contact is here. After creating the mimic, we connect them to an object. You see number 1 here and number 4 here. It means that this is object 1, this is object 4. And this object, this number that we have dedicated to this mimics, is basically connecting the this mimic behavior of this mimic. It's connected. This number connects it to the OR logic. So in OR logic, we can say that close the object 1, and then this the status of this contact will turn to closed. Or this one, for example, object 4, we say close it, this will be closed. What are these measurement windows that you can see? Here we have a table. We can decide which one, what to show here. Right now you can see in the red one, the red square, they have automatically selected these ones. But let's say we want to change to the yellow one also. We want to select something. We want to show the current. Let's not say the current, one input value. Let's say which input, digital input 1 we want to see. This is how it appears here. So let's turn it back. The short is that we can decide what to show in the display of the relay. Mimics are for that. And then local panel configuration. Here it shows that how much the lighting of background light of the this LCD will be, the screen again, how long it should be on and then turn off automatically object control button, for example, what will be controlling the object. Object 1 will be controlled with the control buttons. Mode of the control buttons will be selective or like direct. We can select all of this information are here. We can select, and then disturbance recorder. Here we can select that when there's a disturbance happening, for example, a short circuit in the line, what parameters we want to record, because each of them that we are like selecting like takes memory space for us, and we want to record all of just the necessary ones, not everything. So here we can, for example, you see IA, IB, IC now are selected that these channels will be recorded. I can remove them by selecting them here. Right now those are like they went away, like start and trip. Let's take them off also. Now they become less. But we can again click them and put back, and you can see here that sample rate we can choose 24 per cycle and 48 per cycle. The timing, it shows how much time it takes for the recording. And let's see, system clock. Usually we activate this DST, then we go to the synchronization. We don't do anything here. You can check all of the parameters in the manual. In the measurements, there's a lot of like options. We will work right now with the current and voltage. This like the more advanced you get, you can practice with the others to test to see what the others are. Here we can see like the currents in every cable, every phase, the voltage between different phases, and so on. Let's go forward. In the control, as you can see, the objects. These are the same objects that we want to control in this picture. We had this one object was here and the other object here. We might have other objects that we are not showing here. Just we want to like control those. So when we are talking about object, it means those. So we come here, and then in these objects we have like digital input for remote or local. I suggest you take the manual for all of this, because I don't want to explain one by one. The video will go very long. Here just we put it that it's a locally controlled object for control buttons. Control buttons are these two buttons that we had, like 0 and 1. What should they control? We say object 1, the type is selective. Later we check that in the manual. And then object 1, object used for the circuit breaker is this object 1. Then later object for the truck, object 2. Then here we can say that we have like 10 different objects, for example. Every object can be controlled for like opened and closed with some digital input. Digital input 1, 2, for example, is set for this one. For this one, opening is set for this, but closing is not set. So that's just the objects names for the inputs. This just go through all of them one by one. For inputs, name for the logic outputs, like program logic, I will talk about program logic. Like we want, based on the some inputs, press function button, digital input, the situation of the like the value of the output. we want to make a logic and give set some alarm or set some LED. So we have a way to create the logic here. Here basically we have a bunch of AND and OR gates and some blocks that using them we can make the logic. For example, here's TCS alarm. It says that if circuit breaker is open, digital 1 is high, and the digital 2 is high, a digital input 2. Then if they are given to the input, the XOR gate, you can see the XOR, the name of the gate is here, logic gate. Then this is, for example, RS. It will be set. If this one gives the true, it will be set. And if this one, which is AND gate, it's not logical here, need to be more than one input for this. But right now, if this, anyways, it is like if this one gives signal, this will be reset. And when it's set, this TCS alarm logic output will be on, and then we can connect it to also some LED output or whatever object to be set. So this is one of the ways to make the logic. You see all of the gates are here. And the other way is in the matrix that we can make the logic, but we will reach there. Release latch here is important. For example, right now it is with what digital input you can release all the errors. For example, the clear alarms, you can here select with what digital input, or I think there was even function. Yeah, function buttons. So you remember on the relay, we have this F1, F2, F3. You can use them, select them, for example, here for releasing clearing the alarms. Digital input to clear all alarms. In the beginning, there is nothing, but you can set it. This can be one function for one of those function buttons that are on the panel. Timers, different timers that can be activated. Names of the LEDs, all of the LEDs that I mentioned, they have a name. You can define names for them. Names of the function buttons, you can define name for them. And all of these names that you are defining in this part, they will come to the documentation and show up here so that you can print labels for them. So let's go back here. Function buttons, you can select object for them to control. Digital inputs, you can put names. You had names on them here. You select polarity, delay. They are the detailed settings for it that you should check the manual for them. Names of the output relays, all of them are here. Names of the virtual outputs, like a lot global trip timers. You can set their values. Let's go to the next, which is the protection. In this protection tab, you can select from all of these protection functions. There are different functions for protecting against overheating, overcurrent, or frequency, different non-synchronized voltages, whatever. There's a lot. Later we check in the manual how to get to know them. Here you can see here there's disabled, enabled, and all. If you have all selected, everything that is here is shown. If you have enabled, activated, only the functions that are enabled will be here. And then here is the list of all of the functions. Then we have the disabled functions, but let's see just all of them. For example, let's go, we want to like phase over current, we want to like use this one. We select it, and if I click here, for example, this will be enabled. I'm enabling this function for the over current. What are these setting groups? These are basically if we want to control the like protect the object based on two different sets of the settings in different conditions. So for example, simplest, it's not practical, but in a daytime, you want to protect the motor with higher like levels for the current. You set it like group 1, and this is the default. And then you activate group 2 also. But for group 2 to be activated, you put in the logic a condition that, for example, digital input 10 should be high so that the controller will use this group 2. This is that you have many of them active, and you decide which one should be used in different situations. I don't explain much because it gets more complicated. What are these numbers? Like if you click here, you can like group protection. You see this 5051. What it means, it's basically ANSI code for this protection function. Let's go to another protection. Let's go to this one, for example. What metric protection? And here you can see the number is 32N. Here's 32N dash 1. This is basically the specific ANSI standard code for this function. Every function has an ANSI code. So yeah, when you see this kind of numbers, like 46BC1, this is the ANSI code for this function. Let's go to the next one. I don't want to waste more time. The matrix is another place that we can create logic, and we tell when, for example, one input is high, what other like outputs or logical logical outputs or yeah, outputs to be high. For example, this is basically a network like this, and if you click, there's 3 states for each of these cross sections. For example, general start 1A, we have this input here, and then we want to connect it to the digital output 4. So general start 1 to digital output 4. Right now, there's no dot here like this, so they are not connected. If I click it one time here, it becomes a dot. Blue means it's showing me something has changed here. So right now, general start 1 is connected to the digital output 4. It means when general start 1 becomes high, digital output 4 will become high also. And when general start 1 becomes low, digital output 4 will be low also directly. But if I click here one more time, this second circle comes here. This is a latch. It means that this is working as like SR function, that it can set it, but it when this turns off, it doesn't turn off this one. We have to use another command for turning off the digital output. So If there's no dot here, it means there's no connection between the like row and the column. If there's a dot like this, it means they are directly connected, and if one turns off, the other turns off. If there's this second circle, it means when this is set, the other one will be set, but when this is reset, this one, the other one will not be resetted directly. Here is like output matrix. We are like selecting all of the outputs, which one should be on. Here you can see how much inputs we have. All of the inputs, like inputs can be, I guess there was the function buttons even here you could select, but you should check it, like virtual inputs, digital inputs, other functions, outputs, or trips. So LED matrix, you remember we had this LEDs here, these LEDs that are here. We can decide in this matrix when they should be turned on and off based on the outputs of the, again, all kinds of outputs that we have to see based on depending on their situation when we want them to be on. Like when global trip is like activated, I want the trip to be on. For example, I want LED, this LED also be on. I will activate this one also. I connect it to multiple. You can connect one input to the multiple ones so that in your logic you are like you can see that like what's happening. Block matrix means you might have different functions active, and as we had in the protective functions, sometimes you don't want that function to work for a while or permanently until you give some signal. You can decide that, for example, with one signal, like let's say with one digital output, let's search here DI1. Okay, I searched the digital input 1. I want, when I press the digital, set the digital input 1, I want to deactivate, for example, this 51C function. So this will block it from working. Even though I have this 51C active, if I have, right now I don't have, but if I have activated, when digital input 1 is pressed, this one will not work because I am blocking it from working. This is a function that I am blocking. Like the other one, like 5051 that we have actually active. Let's block it with this. And like that, I can send one signal to the digital input 1, and with that, I block 2 of the functions, for example. But right now, I don't want that. Let's see everything again. So you get the idea that you can decide when, based on what inputs, to deactivate some of the functions that you have. Okay, let's see what is the object block matrix. We had the blocking for matrices, blocking for the protection functions here. Now we have block for the objects. Like we have some switch that we don't want it to be working, as changing situation. When we have like some input on, like a door is open. We don't want that to work. We can block it here. Object block matrix. Then we have the auto recloser that is a bit more advanced. We can learn it later. Then general signals like matrix that we can decide which one of the trips will be active based on, again, all of those inputs. Let's go to the next one. It is getting again very long, 35 minutes. So we have the log that here we can, better to see it yourself. This will not disturb our practical work. You just check the manual for this. In the communication, if we want to, okay, sorry, in the communication, if we want to like set the IP address for our like for our relay, we can set it here, and then there's IP1 and IP2. So you can like set those IPs here, like which one should be used. All of them are here. That is related to the communication. In the device test, you have this. The most important thing is this one, this code. This code is basically has inside it all of the information of the hardware that is connected to the relay, different modules, different um, like uh, abilities, functional abilities that it is added to it is here. Relays, virtual inputs. This yeah, and the like the picture of the local panel display. In the documentation, all of the labels that we had, we can see all of the namings that we have put for the functions, buttons, or these control buttons. We can use this. We can see them and then print them. So this is how we create the program. And if we were like connected to the relay, we would have two. You can see here, there's device that is right now inactive because we don't have a device. If we had a device, we could select to work on the file or the device. And then when the file is ready, we want to copy it to device, copy view to the device or copy all to the device. View to the device will make only the changes that I have made in this screen. And it's very short, and so it is good to use it. But if you press, for example, here, copy all to the device, it will be resetting the device because it is like basically uploading everything to the device. And first is copying to the device, and then you have to write it to the device again. The write and read is not here because we are not connected to the tabs are not here because we are not connected to the relay. Is there anything else that I could say? Let's go forward. That is the part one completed. Let's go to the second part. How to use the user manual. The abbreviation part, make sure to read it. Let's go to the course. I wanted to show you the course material. This is our course. In there's the study material, and if you come to the here user manual, Easergy P5, and then click on this one, it will open the manual for us. It's like 708 pages, so the easiest way for finding things is use the search abbreviations. Let's go here. Abbreviation. It shows all of the abbreviations that we have in this book. Better, this is a necessary part that you should check. The schematic part also we would have, I would like to show you. These are the connections that every type of the model has, like how the connections are, input, output, how the modules are, the connections to the here, for example, each model uh, how what kind of possibilities it has. Some of the modules are free. For example, A, B, C might be here. The other C's are just like uh, empty, for example. I want to find the connection. Like uh, when you want to here the connections basically are showing how we have to bring the like the CT wires to our relay, to which inputs we should connect. For example, like here you see the current, one of the currents comes here, then they are connected all to the neutral. So IA, IB. This one is, for example, the CTs and neutral current measured by the. So these ones we will study in the exercises to see what is the differences of the connections. Let me go to the next part. The abbreviations was important. The connection diagrams we will study together. Selection guide by application. Control C. What is the selection guide? Let's search it here. Control V. And selection guide basically is giving us a simple way, like the short way to select for different kinds of applications, what type of the relay we need to select. For example, if we want to spatially protect the against the voltage, or if you want to feeder is basically the like the cables, the power cables. Wherever you see feeder is the cable. Transformer, motor or line protection. So if you want to use the P5X20 family and you want to like uh, protect against the voltage, over voltage or under voltage, you use this PV20. So it is very limited. It's just like specially designed for the voltage. If you use the universal, for example, you can use for feeder, for transformer, for the motor. So for the line, especially for line protection, you don't have a P20, P5X20 option. You have P530 option. That is this one. So these middle letters that you can see here, U means universal, V means voltage, F means feeder or cable, T means transformer, this one, M means for motor. So for spatially controlling the motor, you can like select this type of the relays, or line protection will be this one. So this was just short to know how you can select the relay for different applications. Let's go to the next one. Or relay is, yes, Easergy P530, which is the feeder protection specialized relay. Let's see, we want to find two different like descriptions. We don't know what is the selective mean, or selective or direct control. Let me highlight this. We want to know what they mean. What is selective or direct highlight? Let's go to here, Control C. Very shortly, I am going to manual. Let's paste. Here is the configuration, local panel configuration. If you scroll down a bit, I/O, local panel configuration. Where should the, let's see the next, the next one is here. Controlling objects, the you want to control the objects. We have this, like these are our objects. We want to control them with these two buttons, O and 0 and 1, basically. We want to select, you remember in the P5 here, we had in the control objects, selective and direct. We want to see what they mean. Like where was that in general control panel, or here, this one actually, selective and direct. We want to see what they mean. So we went on this one, local panel configuration, selective direct part in the manual. And now we can read when the selective control is enabled, when direct control is enabled, how it works. Basically, the buttons will work in a way that like press the 0 on the local panel to open the circuit breaker or stop a motor, for example, or press this 1 for starting the motor. Then you have to press it again one more time to confirm it. But if you have the direct, then you don't have to confirm it anymore. The object control acts according to your control like operation. Here you had to confirm again, but in this one you don't have to confirm. So you can detail read what it means, the selective and the direct. It's just specific to here, maybe like to this relay. So the manual is the only source that you can get the valid information. Let's go to the next part. What was that? Not this one. The next thing we want to, for example, select the under voltage protection. In the protection function, we want to activate the under voltage. Control C. Let me go to the Easergy under the protection. Let's search for under voltage. Under voltage, and C number is 27.1. Okay, let's go here. We want to activate it. I activated it. Now I don't know what are these parameters. Pickup value, CB open blocking. This one, CB open blocking, measurement mode. CB open blocking, we want to know what it means. So we go here in this one, Control V. Yes, we go to the under voltage. We have come to this, like in the chapter, protection functions is the chapter. Then we have the under voltage. Describes what it does. Example of the configuration curves that is giving us reset relay, blocking voltage transformer, use failure operation mode, 3 independent stages. The block diagram is very useful for understanding how the parameters that we are setting together are working, because this function is installed in the relay. We just set the like for example these parameters, and based on the input voltages that is receiving, it sets some trip or some output, depends on what is the logic. So these are the block diagram for that, and then block diagram for tripping logic is a simplified model. The tripping logic, what logic we can make in the control basically. select setting, alpha 3 phase, for example. All the parameters also characteristics are like open blocking, CB open blocking options on and off, like this one. All the parameters are here. And then this is another protection functions. So all the information that we need about this, we can come dig in the parameter to see what is the open blocking do, like this one, for example. In here, this is a OR function. So open blocking, block, and this one, they are all coming from different places in the logic. So when you are setting the open blocking, basically you are setting this one. You give one side to AND to each of them, like for all of the voltages. Okay, that is the part that I wanted to explain here. The last part is the how to read and write the program to the relay, to and from the relay, is related to when your program is ready, you are connected to the relay, you just need to write the program to the device, and then it will take a few minutes, reset, and then you can see everything. Okay, I think it's enough for today, and if I see some other topic that I need to make a video, I will make later. So yeah, thanks. So